Welcome to Matter and Properties. We're going to talk a little bit today about what matter is and how we can describe it, and then we're going to wrap up by talking about the states of matter: solids, liquids, and gases. To start us off, we're going to sort of review a little bit what matter is. And we talked about this a little bit in class, but matter is anything that has a mass and a volume. So it has to have some substance, it has to be made up of some stuff. That's the mass, we can measure that. And it also has to take up space, it's a volume. Both things we can measure, and both things are required for something to be considered matter. And that's going to cover most of the things that you would think about anyway. The air you're breathing is matter, you're made up of matter, what you're sitting in is matter. So if we compare that to things that are not matter, so not matter, start getting a more complete picture here. So things that are not matter, we have light is not matter, electricity is not matter, heat is not matter. You may be starting to get a inkling of what I'm talking about here, but these are all energy. And all things in the universe are either going to be energy or matter. Alright, so chemistry is the study of matter, but more specifically we're interested in three things: the composition of matter, the structure of matter, and the properties of matter. Now these three things are all sort of tied to each other, so let's talk about what they are. Composition is what matter is made up of, the elements that makes up, the substances that make it up, really what the stuff is. Structure is how that's all put together, how it's organized. And these two things are going to feed into properties. So our properties tell us a number of things. And properties are kind of the big deal here. They can tell us about the features of a substance. We can use them to describe matter. But the really big deal about properties is that they also tell us how matter is going to interact with other matter. So interactions with other matter. And that's going to be really big for chemistry, because we're going to be interested in how substances interact with each other, how matter interacts with other matter, and properties are going to be a big part of that. In this lesson, we're going to be focusing on how to figure out what are the types of properties and then how we can use them in describing matter. So let's start with two we've already talked about today: mass and volume. These are going to represent our first type of property. Okay? These are both what we call extensive properties. Okay? Mass and volume are both examples of extensive properties. Now, an extensive property is a property that depends on how much of a substance there is. If I take a block of wood, it has a particular mass and volume. However, if I cut that block of wood in half, I now have less. Okay, so there's going to be, the mass is going to go down, the volume is going to go down, and those two properties have changed because the amount of substance that I'm looking at has also changed. Okay, so these two things depend on how much of the substance there is. We can sort of compare that to intensive properties, and those are the opposite. Okay, intensive is the opposite. These are properties that it doesn't matter how much of a substance you have. The only thing that matters for intensive properties is the identity of the substance. Okay, so intensive properties. Let's give a couple examples of those. Malleability. Malleability. Malleability is the ability of metals to bend, and we can see that with a spoon. Okay? You can bend a metal spoon, and it doesn't really matter how big of a spoon it is. You can still bend it because that's a property of the metal. Magnetization is another intensive property. Okay? If a material is magnetic, it doesn't matter if you have a lot of it or a little bit of it, it's still going to be magnetic. There are some other ones, such as melting points and boiling points. Let's get those down, those are important. melting point and boiling point. Okay. These are properties of substances that also don't matter how much of the substance you have. Water, for example, is always going to boil at 100 degrees Celsius no matter how much you have. So that's an example of an intensive property. All of the properties we've talked about so far, intensive and extensive, are all physical properties. What that means is we can observe or measure those properties without changing the identity of the substance. Okay? For example, you could measure the mass of that wooden block, but it wouldn't change the fact that the block is made of wood. You could tell that water boils at 100 degrees Celsius, but it'll still be water when that happens. So those are all physical properties because when you measure them or observe them, you don't ever change the identity of the substance. I'm going to pause the video right now and give you a chance to come up with a few physical properties on your own and add them to your notes. Alright, great. Now that you have some of those written down, I want to talk about what happens when we change properties. So I have a cookie here, and this cookie has several physical properties. The shape is a physical property, the size, the volume, how much space it's taking up, how hard it is, how crumbly it is. These are all physical properties. The mass is another physical property. Now, if I change one of the physical properties, say by taking a bite out of it, I'm changing the physical properties. You can see now that very clearly I've taken a bite out of this, and the mass has changed, so I ate some of it, and all those other properties I just mentioned have changed, the shape, the size. Some of them have not, though. It's still just as hard as it was before, just as crumbly as it was before, so I've only changed some of the properties. Now, I think we can all agree it's still a cookie. So what I just did is called a physical change. This is where you change one or more of the physical properties without actually changing what the substance is. Now this is going to sort of help us go to our next section here. Another physical change that's very common is when you melt an ice cube. Okay? So ice is a form of water, and when it melts it becomes liquid water. We call that a change of state. That's another kind of physical change, and we're going to start talking now a lot about the states of matter.